Yeah, well, lads, I said I'd just do a quick video on the assignment that I gave you. So I gave you the assignment to read pages 184 to 193 and then answer the 5 questions on 194. Okay, so I got a few emails there saying that they didn't really understand. They tried their best at the 5 questions, but they kind of found it difficult to understand and how to figure them out on their own. So, look, I do understand that it can be tough to figure this out on your own, and it can be tough to teach yourself to do this kind of stuff. So, anytime it's necessary, what I'll do is I'll just put a little video running through it. I know it's not going to be as good as me going through it in the classroom, but it's another helpful resource for you to learn the content as well. All right. So we'll just go through this, and then hopefully this will give you better insight and you'll be able to answer the questions. Okay, so starting off, so a chain and belt drive. Okay, so chain drives and belt drives are similar to gears. So they're similar in that they connect wheels of different sizes together. However, the wheels do not mesh together. Instead, they are connected to each other using a chain or a belt. Chain and belt drives have a driver gear and a driven gear, just like our normal gears do. So turning the driver wheel causes the driven wheel to rotate, except the only difference is it happens through a chain. So you can see here we have our whatever one is our driven, whichever one is our driver. The same thing happens once one turns, the other one turns, except they're not connected together, they're connected using a chain. Okay, so if the two wheels are different sizes, chain and belt drives will change the output speed of rotation and output torque. Okay, so we'll look at that later on. Okay, so chain and sprocket. So in a chain and sprocket mechanism, the tooted wheels, called sprockets, are connected via a loop of metal chain. Okay, so we have our sprockets here, and they're connected via a metal chain. So each sprocket has a set of teeth which fit into the links of the chain. So you can see here, each sprocket has a set of teeth. You can't see these teeth because they're already connected into the chain. Same on this here. Okay. So chain and sprocket mechanisms are very strong, do not slip easily, but need to be lubricated with oil or grease to reduce friction and prevent sticking. Okay, so sometimes in your junior cert, what you might get a question asking you what's the advantage of using a chain and sprocket mechanism over a um, tooted belt and pulley. Okay, so they're your advantages. That's the reasons why you use a chain and sprocket mechanism. So the uses of the chain and sprocket mechanism. So they're using bicycles where the chain is connected to the rear wheel to the pedals, so you can see clearly there. Cars where a chain called a timing chain or a timing belt. Sometimes in cars you'll have a timing belt, which means if it's a timing belt, that means that there's no sprockets. It's just connected using a pulley and a belt. Okay, so you might hear maybe your fathers, your uncles, your granddad maybe talking about a timing belt in their car. The timing belt's gone in the car. Okay, sometimes you could be talking about a timing belt, or you could be talking about a timing chain. So at least now you know the difference between the two. So this is used to connect the crankshaft to the camshaft. So C mechanisms one. Okay, so we've kind of gone through that already. Anyway, that never really comes up too much in the exam, so it's fine. Okay, so now belt drives. Okay, so this is what I was talking about. In this mechanism shown below, the wheels are connected using a belt. So in this one here, we were looking at connecting a chain, but this time we're using a belt. So you can see the belt here. Okay, so the belt is in the shape of a loop. So pretty much the same as our chain and sprocket, but it's usually made from rubber. So this is made from rubber. So the wheels are called pulleys. They have a groove along the edge to keep the belt in place. Okay, so you can't really see it here that well, but what we'll have in here, there'll be a little groove just inside the pulley. So this here's our pulley, this here's our belt. So there'll be a little groove inside our pulley for our belt just to slide into. Okay, so the belt drive operates more quietly or quieter than a chain drive, but the belt must be kept tensioned tightly against the pulley wheels or it may slip. Okay, so the pulley and the belt drives, they do have advantages over the chain and sprocket. So one advantage of this compared to the chain and sprocket is it works an awful lot more quieter, and it also doesn't need any real amount of lubrication. So you don't need to put any oil or any grease on it. but again, if it's not tightened up correctly, it will slip. So at least you know if you're using your chain and sprocket, once it's there, it's going to stay there, it's not going to slip. Okay, so belts are not good for high force applications, so lifting heavy loads, as the belt may slip against the pulley wheels. Okay, so if you want to lift a heavy load, you're probably better off using the chain and sprocket mechanism. Alright, so tooted belt. So in a tooted belted system, seen here on the right, the belt has teeth on the underside which mesh to the teeth of the wheels. So you can see here it's the same principle as our belt and our pulley, except the inside of the belt is just tooted and it connects to the underside of the teeth of the wheel. Okay, so tooted belts have a better grip than flat belts, obviously enough, and this means that they are less likely to slip. Tooted belts are commonly used as timing belts in sewing machines, ink printers, and to drive the camshafts in a car engine. Okay, so this is what I was talking about here. Okay, so using in timing belts. So that's what a timing belt would look like inside your car. Okay. So chains versus belts. So the advantages and disadvantages. Okay. So a good few times the question will come up about what's the difference between a tooted belt drive or pulley and belt and a chain and sprocket, and you'll have to give advantages why, which one is better compared to the other. Okay. So the advantages of the advantages of the chain drive. So it's non-slip, it's stronger, it's more durable, and it's suitable for higher output torque. So basically, it's required to lift heavier loads. Disadvantage, however, it's noisier. It needs oil for lubrication, so it can get stuck or it can rust otherwise if there's no oil or grease on it. So with your belt drive, it's quieter, it's lighter, it's cheaper, and it doesn't need any lubrication, so it doesn't need any oil. And then the disadvantages, however, are it can slip, but we did say that our tooted belts have a lower chance of slipping, but that does not mean that they won't slip either. So it's not suitable for high output torque. So if you can imagine, so we said an application of our chain and sprocket was on our bike. So if you can imagine, instead of our chain and sprocket here, we had our belt. So what do you think would happen if we wanted to cycle fast? So let's say we had to cycle fast and we pushed down really hard in the pedal here. What would end up happening was the pulley would just rotate and it wouldn't be connected to the belt, and the belt would just slip, so we actually wouldn't create any torque or any output force. So that's a main application or main reason why you use chain drives over belt drives for a higher output torque. As I said, there is other benefits of the belt drive compared to the chain drive. So if you wanted something to work quietly, or you wanted something in a lighter and cheaper, you use your belt drive. So past exam questions. So these are the questions I was talking about. Okay, this rowing machine uses a chain drive. So give 2 reasons for using a chain drive for this purpose. Name 2 other machines that use a chain drive. So the solutions for this. So reasons for using a chain drive in the rowing machine are: it will not slip easily, whereas the belt drive may. So consider the rowing machine to be subject to strong pulling force. So if you go to the gym, you'll see that if you ever see anyone on the rowing machine or you ever use yourself, in order for you to use, you have to pull back an awful lot of force back in this direction. So if you're using a tooted belt or a pulley in a belt, it would probably slip if you pulled it too hard. So that's why you use a chain and sprocket. A chain drive is made from metal, so it will be strong and durable. The metal chain will withstand the force of being repeatedly pulled by the rower better than the rubber typically used in a belt. Okay, so it just basically means it's more durable, it's going to last longer. So if you kept pulling the belt, it would probably create a lot of friction, which in turn would just end up wearing away at the belt, and it might just snap eventually. And then see, a chain is flexible and will accommodate different heights and sizes of rower, as opposed to the non-flexible mechanisms such as a rack and pinion system. Okay, so they're talking about a completely different system there, so I won't worry too much about that one. So the A and B are your main 2 answers there. Okay, so 2 other mechanisms, 2 other machines that use the chain drive are a bicycle and a car. So it's straightforward enough. Another work example or another past exam question are: state 2 reasons why a pulley and tooted belt is used instead of a gear and chain on an inkjet printer. Okay, so this is one of the reasons, or this is one of the questions that I was talking about. It comes up quite a bit. So they're asking you, why would you use a tooted pulley and belt over a chain and sprocket or a chain drive? So first of all, they're asking you, why would you use an inkjet printer? Okay, so an inkjet printer is just your normal printer. So it's quite small, it's quite compact. So that means that you want to be able to carry your printer around. So you don't want a big heavy chain and sprocket mechanism inside it. So first of all, the tooth and pulley belt is lighter, it's cheaper for starters, and there's less noise. So you can know anyway. You probably hear if I was in the class when I was printing some, there is quite a bit of noise out of the printer when I'm starting printing some, but it would be louder if I had a chain and or a chain drive or a chain and sprocket mechanism. Okay, so the tooted belt is also easier to replace than a chain drive, and the chain drive is not needed as a large torque is not required. Okay, so there's only a small amount of torque required. Okay, and also if let's say we were using the chain and sprocket or the chain drive in our inkjet printer, we would have to constantly lubricate the drive. So now this next section is important. Okay, so for your calculations you need to know the following formulas. Okay, so if you haven't got these taken down, I would 100% take these 3 formulas down. They are vital in order for you to understand how to answer any calculating question around the tooth belt pulley and also the chain and the chain drive. Okay, so make sure you have these taken down in your copy. These formulas here are everything you need to answer the questions. So the speeds for chain and belt drives are calculated in a similar way to gears. So we looked at how to calculate our gears. So remember that speeds of rotation are measured in RPM, so revolutions per minute. So first of all, velocity ratio. So velocity ratio is equal to the speed of the input wheel divided by the speed of the output wheel. So this is dependent on the circumference of the wheels. It can also be calculated using the following formula. So this is just for our belt and pulley now. Okay, so there's 2 different formulas. 2 of them are very similar anyway, but 2 different formulas. One for belt and pulley, and then one for our chain drive and our tooted belts. So we'll go with our belt and pulley first. So this has no teeth on it. Okay, so the speed of the driver gear is equal, or sorry, the speed of the driver gear over the driven gear is equal to the diameter of the driven wheel over the diameter of the driver wheel. So because there's no teeth on our belt and pulley, it's the diameter of the given wheel. Okay, remember we said we're a double-decker bus. Okay, so just take your double-decker bus every time. So double-decker bus, the driver is always on the bottom. So if you get into a double-decker bus, the first thing you win, the driver's on the bottom. You're the person being driven, you sit on top, or you can sit at the bottom, but you have the option to sit on top. The driver cannot sit on top. The driver is always on the bottom. So that is our belt and pulley formula. Okay, so the velocity ratio for chain drives and tooted belts. Okay, so because it's a tooted belt, it's number of teeth on the driven wheel over the number of teeth on the driver wheel. Okay, again, just think your double-decker bus, driver on the bottom, driven on the top. So once you have calculated the velocity ratio, you can then calculate the speed of the output wheel. So if someone, usually what you'll ask is, given a certain amount of information, calculate the speed of such a wheel. Okay, so first of all you have to calculate the velocity ratio in order to get the speed. Okay, so output speeds. Once you know the velocity ratio, you can calculate the speeds of the output wheel as follows. So the speed of the driven or the output wheel is equal to the speed of the driver, so the input wheel, over the velocity ratio. So usually you'll always be given the driver speed anyway. And you'll have to calculate the velocity ratio from that and then calculate the output speed, so the driven speed. Okay, so we'll have a look at this one. Okay, so calculate the speed of the driven pulley from the information given. So we have our driven pulley here, so it's a pulley. It's not a tooted pulley, it's just a pulley, so there's no teeth on it. So that means we're going to be using this formula. The velocity ratio for a belt and pulley. Sorry. So our driven pulley is 30 millimeters. Our driver pulley is 15 millimeters. Okay, so we go back up. First of all, we have to calculate the velocity ratio. So our formula for velocity ratio is the diameter of the driven wheel over the diameter of the driver wheel. So driven over driver, so driven, so 30 over 15 is equal to 2. So that means that our velocity ratio is 2. Okay, straightforward enough. So I'll do that again. So the formula is diameter of the driven wheel over the diameter of the driver wheel. So driven over driver, so driven is 30, driver is 15, so 30 over 15 is equal to 2. So that means that our velocity ratio is equal to 2. So now that we know our velocity ratio, we can calculate what is asked of us. We're asked to calculate the speed of the driven pulley. So we're able to do that. So now that we know the velocity ratio and we know the speed of the driver, we can calculate the speed of the output wheel. So the formula is the speed of the driver wheel over the velocity ratio. So we know the speed of the driver wheel is 150, and we know from calculating that our velocity ratio is 2, so that means that 150 over 2 is equal to 75 RPM. Okay, so that's your final answer. We'll do another one here again. So this here is a small bit different. The reason that this is different is because there is a tooted belt. So that means that we're not going to use the same formula as we did there. We're going to use this one instead. So the number of teeth on the driven wheel over the number of teeth on the driver wheel. Okay? So calculate the speed of the driven sprocket if the driver is rotating at 20 revolutions per minute. Okay? So sometimes they give you a diameter, sometimes they give you a number of teeth, but it's always the driven over the driver. So think of your double-decker bus. If you can just nail that double-decker bus thing down, you will understand an awful lot of these equations. Okay? So driven over driver, so that means 20 over 60. So if we put 20 over 60, it's going to give us 0.3333 and so on, or 1/3. So that's our velocity ratio, because we use the driven over the driver. So our driven here is 20 teeth over our driver, which is 60. So 20 over 60, because our formula is always driven over driver. So that means 20 over 60, which gives us 0.33 or whatever, or also 1/3. So now that we know that's our velocity ratio, we can calculate the output speed. So the output speed, how do you calculate the output speed, or the speed of the driven wheel, is always the speed of the driver wheel over our velocity ratio. So we are already given here in the question that the speed of our driver wheel is 20 revolutions per minute. So if we put 20 over 1/3, or 0.3333, what that means is basically we end up multiplying 20 by 3. Okay, so if you put it into calculator, it doesn't matter where you put it into calculator, you put it into your calculator like this. But if you divide it by a number below 1, you end up just going to multiplying it, if you understand. But anyway, if you don't, just work in this way. This is the same way. It's just where you get the same answer. So if I put this into calculator, I'd still get 60. If I put this into calculator, I get 60. Doesn't matter what way you do it. Okay. So if you don't understand, you can go over that video and you can listen to it over and over again. Okay. So move on. You could try and answer these questions. Now, these questions aren't the questions I want you to answer, but if you're struggling, answer them questions. You can send them on to me. I'll correct them for you. If you're still struggling, but you can listen. Look at key points there. If you're still not understanding it, there's key points there. Make sure you know your formulas. Try and answer these questions on your own. If you want to send them on to me, I'll correct it. That's fine. But continuing on anyway. Okay. So pulley systems. So a pulley wheel is a wheel with a groove in the rim to hold a rope, cable, or a belt. So there's a pulley wheel there. Okay. So we have seen pulley wheels in use already in belt and pulley mechanisms in the previous section. So we've looked at it already. In the last section, we looked at our pulleys and we looked at our belts. So this was where 2 pulley wheels were used in a continuous loop or belt. So we'll go back up here. I'll show you a picture of that exactly. You can see here you have your 2 pulleys. So one pulley here, and you have a belt, and it's in a continuous loop. So it goes round and around and around and around and around. So come back down here. So this section looks at pulley systems which consist of arrangements of pulley wheels with ropes or cables designed to lift weights or move loads by using mechanical advantage. Okay, so that's kind of an introduction to what a pulley system is. Okay, so first of all, Key definition: a pulley wheel is a wheel with a groove in the rim to hold a rope, cable or belt. And a pulley system is an arrangement of one or more pulley wheels and ropes or cables designed to lift weights or move loads using mechanical advantage. Okay, so I take them two definitions down. That basically sums up that paragraph in 2 sentences. So remember that the mechanical advantage of a mechanism is the ratio of the output force to the input force. So the mechanical advantage is always going to be the same. It's load over effort. It's always load over effort, no matter what mechanism it is. So, single fixed pulley. So, the simplest pulley system has one pulley wheel attached to a fixed axle. The rope is fixed to the load. In order to raise the load by a given amount on one side of the pulley, the user must pull the rope down by the same distance on the other side. So that means here, you can see here, so the simplest pulley system has one pulley wheel. Our pulley wheel is just here, and in order, the rope is fixed to the load, so you can see the rope here is fixed to our load at the bottom. We can also see it says here that their pulley wheel is affixed to an axle, so your axle is here, so your pulley wheel is fixed to this, your load is fixed to your rope, and what it says here, in order for us to move this up, we have to pull down this way. So it also said the user must pull down the rope the same distance on the other side. So if we want to move this 1 meter, we have to pull this 1 meter this way. If you want to move this 2 meters up this way, you have to pull this down 2 meters. Alright? So the pulley only changes direction of the pulley, of the pulling force. So it only changes the direction of the pulling force. So there is no mechanical advantage, so the forces are equal on both sides. So that means if there's no mechanical advantage, the mechanical advantage is just 1, okay? So, however, single fixed pulleys are still very useful because it is easier and much safer for a person to lift a weight by pulling down a rope than it is to try and lift the heavy weight directly. So if you wanted to pick up a heavy weight from the ground, it's tougher to do that than it would be to attach to a rope, attach to a pulley, and then just pull the rope down, and you'll be able to lift it quite easily, okay? So where a mechanical advantage, you just have to know the mechanical advantage of the single fixed pulley wheel. You just have to know them. Single fixed pulley wheel is 1, okay? So single fixed pulley wheel is just mechanical advantage is always 1, okay? So moving on. So a single movable pulley. So in a single movable pulley, the pulley wheel is attached to the load at the end, and the end of the rope is fixed. So, just to go through that, a single movable pulley, the pulley wheel, which is here, is attached to the load. So you can see that our pulley wheel is attached to the load, and the end of the rope is fixed. So the end of the rope is fixed to our axle again. So this causes the weight, i.e. force of the load, to be shared between 2 ropes. So that means that it's shared between this rope, but it's also shared between this rope here. So if it's shared between 2 ropes, it only takes half the force to hold up the load on the other side, because already half of it's been held up by this here. Because the fixed point is also sharing the load in the effect, and in effect holding up on the other half. So now that we have a mechanical advantage of 2, so we know that we only have to put in half the effort, that means we have a mechanical advantage of 2. So we can hold up a given force with only half the, or we can hold up a given force with only half the effort, basically. Notice that if you lift up the effort side of the rope by 1 meter, it will only rise up by 0.5. This is because the rope is doubled over, okay? So there is advantages and disadvantages, okay? So it is half the weight, but because it's half the weight, because it's split over the 2 ropes, that means that we have to double the distance we pull it by in order to move it, okay? So let's say this was 20, we'd only have to put, let's say the weight or the load was 20 kilos, we'd only have to pull this by 10 kilos in order to lift it up. But if we wanted to move it by 1 meter, we'd have to pull it by 2 meters in order to move it by 1, okay? So there is advantage and disadvantage. So we see, just like in the case of the lever, there's a trade-off between distance and force. So if we lift a load with an effort equal to only half its load, we have only applied the force over twice its distance. So that's they kind of explain that, and it's awkwardly phrased, that little two sentences there. Okay, so basically what that means is, if this is 20 kilos, we only need 10 kilos basically to pull it up. But if we want to move a 1 meter, we have to pull it 2 meters. So if we want to move this 1 meter, we have to pull this rope 2 meters in order to move it. Okay, so mechanical advantage, again, you just have to know what it is. Mechanical advantage of a single movable pulley is 2. So now, one fixed and one movable pulley. So what is the mechanical advantage of the pulley system shown on the right? Is it twice as much because we have twice the number of pulleys? So we'll find out. We can see from the diagram below that this pulley system is a combination of a single fixed wheel pulley on the left, so a single fixed wheel pulley, and we also have a single movable pulley system on the right. So we know that the fixed pulley system doesn't have any mechanical advantage, it just changes the direction of pulling. So the total mechanical advantage of the system is 2, because we know that our single movable pulley has a mechanical advantage of 2. So again, in this case, you can lift a given weight with half the effort, but you'll also have to pull the rope twice as far. Now, there is an advantage of this, okay? So we say that the only real purpose of our single fixed pulley is it changes the direction we pull. So if we had just this single movable pulley, we'd have to pull this rope upwards. I mean, it's quite awkward to pull the rope up in order to lift the load, but because we add in our single fixed pulley, all we have to do is just pull the load down instead of pulling it up. Okay, so that's what it says here. No, the advantage of this pulley system is that the operator can pull down the effort side of the rope. It's much easier and safer for the operator than having to pull the rope up, as is the case with a single movable pulley system above. Okay, so you can see here, in order for us to lift this load, we have to pull this rope up, but we've added this one here, so all we have to do is just pull it down. It's an awful lot easier. So the mechanical advantage of one fixed and one movable pulley is 2. So distance moved. Okay, so this is another one you need to know. Okay, so distance moved for the single movable pulley system and the one fixed and one single movable pulley system, the rope on the effort side will travel twice the distance that the load moves. So we know that already. If we want to move the load 1 meter, we have to pull the rope 2 meters. We know that already. Okay, so how do we calculate that? So in general, the distance travelled by the effort side is given in the following formula. Okay, so distance moved by effort equals distance moved by load multiplied by mechanical advantage. So that's a formula you need to take down. You need to know that formula as well. So I'd have that down in your copies and highlighted. So now a 4 cable hoist. So more complex pulley systems can be created to provide greater mechanical advantages. A common system called 4 cable hoist is shown here. The cable is fixed on the right, so you can see over here that our cable is fixed here. A load is suspended, or a load is a weight suspended from the hook. So you can see here that our load is suspended from here. So the load is shared or divided among 4 cables. So if it's divided among 4 cables, that means the mechanical advantage is 4. But if the mechanical advantage is 4, in order to raise the load by 10 centimeters, the motor will have to pull the cable by 40. However, it only needs a quarter of the force to do so. Alright, so I'll just go through that again. So the load is shared or divided among 4 cables, so it has 4 cables there, 1, 2, 3, 4. So that means it's mechanical advantage of 4. So it's just something that you have to know. I know sometimes it doesn't make sense, but it's just something that you have to know with our pulleys. You just have to know the different mechanical advantages for each pulley. So to raise the load by 10 centimeters, however, that means that we have to pull, or the motor here in this case has to pull the rope 40 centimeters. But it's only going to take a quarter of the force to do so. So another advantage of 4 cable hoist is that the entire pulley systems can be moved horizontally on a gantry bridge frame for supporting cranes without changing the height of the load. Okay, so you can see that's what it's used here for. This type of mechanism is used in dockyards to load and unload containers from container ships. So now an advantage of this, or sorry, example of this. So calculate effort and force or a pulley system. So the pulley system shown lifts a load of 30 newtons, a weight of a pulley system shown lifts a load of 30 newtons at a height of 0.5 meters. So calculate I, the effort force, and also II, the distance moved, so X. So this pulley system has one movable pulley and one fixed pulley. Okay, so we have our one single movable pulley is here, and our one fixed is here. Okay, so if the mechanical advantage is 2, we already know that. How do we get the mechanical advantage is 2? Because we just know that our pulley system has a one movable pulley and one fixed pulley, so its mechanical advantage is 2. That's something we just already know from learning off. So if the mechanical advantage is 2, by definition, this means that the effort required is half the load. So the effort required is half the load. So that means if we have load here, so that means the effort has to equal 15. So if the mechanical advantage is 2, then the effort distance must be twice the load distance. So that means if it's 2 and that's 0.5, so it has to be 1. So the calculation of this, so calculate the effort force. So mechanical advantage is load over effort, but we already know the mechanical advantage of this pulley system is 2. Okay, so if the mechanical advantage is 2 and we know our load, which is 30, so load multiplied by 2 load equals 2 multiplied by effort, but we already know our load, so we can just rearrange the formula. So effort equals load divided by 2, which means 30 divided by 2, which equals 15, and calculate the distance moved by load, X. So distance moved by effort equals distance moved by load multiplied by mechanical advantage. So our distance moved by load is 0.5 multiplied by mechanical advantage, which is 2, is equal to 1 meter. Okay, so these are the 5 questions you have done for Friday. Okay, so these are the key points here. Okay, so the key points here: the mechanical advantage of a single fixed pulley is 1, mechanical advantage of a single movable pulley is 2, mechanical advantage of one fixed and one movable pulley is 2, and the force and distance calculations for pulleys are similar to levers and gears. Okay, so what you can do is you can listen over to this video over and over again. If you've already submitted the questions, you can listen over this video and resubmit them, because I understand it might be difficult to understand the content when you're doing it on your own. Okay, so hopefully this video helped you, and just make sure you have everything submitted by Friday.